저는 Tzu-ping Chung 님께서 You might not think 라는 주제로 발표하겠습니다. 큰 박수 부탁드립니다. Hello, this speaker is Tzu-ping Chung will speak about You might not think. Please welcome him with applause.
Hi everyone, thanks for being here. I know that English talks are at the scarce here, so yeah, thanks for having me here to speak English to a bunch of Koreans. And so before I started, I wanted to ask some quick questions. Has anyone here has experience with concurrency with Python? Please raise. Oh, cool. Not many. That's a good thing for me because then I can maybe show you something that you haven't already known. So maybe about threads. Has anyone used threads? Not necessarily with Python, but maybe with C or with some. Okay, yeah, that's a lot more. And multi-processing. Okay, thank you. And single-threaded asynchrony, maybe with JavaScript or with something else. Okay. And asyncio. Okay, so maybe again, please. 1, 2, 3, 4, 5. Okay, thank you. So, yeah. So, oh, and one extra thing. Has anyone here attended the last talk presented here by Andrew? Okay, so not many people. So you're the lucky ones because you have learned the good things about asyncio, and now I'm gonna talk about the bad things about asyncio. So please don't be mad at me, Andrew. Okay, so a little things about me. My name is Tzu-ping in Chinese, but if you find that difficult to pronounce, I know it is for a lot of people. You can call me by my initials, TP. Or you can, and if you want to follow me on social media or anywhere online, you can just follow Uranus JR, or you can visit my websites. And if that's a little bit hard to type, you can just use this giant QR code. Yeah, I'm a co-organizer with Django Girls in Taipei and other communities there, and I'm also very unrelated to Python. I'm the main author of Markdown, a Objective-C Markdown editor on Mac. Yeah, so you can check it out if you use Markdown a lot. I work at this company. This is a very small company. We do outsourcing for agricultural systems and environmental control in factories. And the reason I started to go into asynchronous is because that we use a lot of hardware to control things. To control a lot of hardware, we use many HTTP requests and use TCP connections and serial connections. And if we always wait for the hardware, our system would be way too not performant enough to do a lot of processing. So I looked into the asynchronous because of that. And I do this the first time maybe in 2014. And I presented some of my thoughts at a Taiwanese conference called OSDC.tw. And yeah, it was good. Hello? Yeah, so the main topic I presented at that conference is mainly about JavaScript because that's probably the main asynchrony thing at the time. But and then the reaction for that talk was pretty good, so I decided that I should probably do it again. So I did at the PyCon 2004 in Taiwan also, and that was 2014 APAC, I think. Yeah, and I had a lot of confidence during that talk, but the reaction was not very good. So I didn't understand why until maybe about a year later. Yeah, so the problem is like this. Python 3.4, which is the first version bundled with asyncio, which is the first official implementation, official as in the built-in library in Python, is released at March 2014. And I presented OSDC.tw at April, but that was pretty much about JavaScript, so it was fine. And in May, I presented asyncio in PyCon APAC, and obviously no one else except maybe myself know about it. So that's the main problem, is that I maybe talked too early. But then 2 years passed, and I found that many people are now using asyncio. For example, like Andrew just built ALFTTP, and it was awesome. And there were a lot of talks at various PyCons about Python. So I figured that maybe it's time again that I talk this again to share my thoughts. I have built our system for 2 years, and I have some experience with asyncio, at least I think so. So maybe I can show you something that maybe you might not want to use asyncio because we have a lot of difficulties building our systems. Yeah. So for those that didn't raise your hand on concurrency, let me just simply explain it. So when we talk about a synchronous system, we're talking about that, say I have 3 jobs here, and for each job I need to process something upfront and then wait for an external output, maybe HTTP or serial or something else, or maybe user input even. And after I got that response, so that's a gap between the 2 blocks. And after I get the response I want, I can do post-processing and finish the job. Okay? So I have three jobs here that are all works like this. So in the synchronous system, I have no choice. I have to do the first thing up front, wait for the first response, and then finish the first job. And after that, I do this again, and then do this again. Now this is pretty okay, except that I have to wait for a response, and each time I need to. And when I'm waiting, my computer is just doing nothing. My program is just being idle. It just wastes time and wastes CPU power. So a solution to this I'm talking about today is single-threaded async. Now, because Python, at least in CPython, we cannot use multiple CPUs without doing multiprocessing. So when I'm talking about async in this talk, I'm usually talking about single-threaded async because I'm assuming that we only have 1 thread. Okay, so in single-threaded async, after I finish the front part of my first job, when I'm waiting for my first response, I can just start the second job immediately because I'm not doing anything otherwise. And after I finish the front part of my second job, I can then come back to check whether I have the response. And if I do, I can finish the first job. And then after I finish the first job, I can either begin my third job, or if I have got the response from my second job, I can finish my second job. Okay, so if I compare the 2 kind of models, you can see that the async model can finish the job a lot quicker because I don't have to wait as much, right? Because when I'm waiting, I can do something else. It's like just kind of like how it works, right? When we are, for example, we build something and we present it to the boss, we can either wait for the boss to approve it, or we can just work on something else. Right, so if we just work on something else when we're waiting for the boss, we can just finish other things quicker. But it's easy to say that, but when we do this in a program, it's just like absolute magic to me at the time. I was first introduced with this in C# when they had a lot of async functions, like they just suffix everything with async, and they just work magically asynchronously. So I was pretty much shocked, and this was just like magic to me. And from what I hear, a lot of people talk about it. It's just like this, right? You were just like injecting a superpower siren, and you just magically become Captain America for your program. But after I have worked a lot with asyncio and other asynchronous frameworks, I realized that this is definitely totally not true. Asynchrony is more like, this is Dante. trading his souls with a demon. So you get the idea. Yeah, it's asynchrony is pretty cool and it's pretty powerful if you use it correctly, but it also has a lot of trade-offs you have to face if you want to convert your system to be asynchronous. So it's not just a superpower thing. Okay, so here's a very simple example. This is our model when I presented earlier. So there is already one trade-off in this simple graph that you can see. The first job is finished later. Even though you finish 3 jobs quicker, the first job is finished later. Why is the case? Because when you have got the response for your first job, you have to wait for your second job's upfront to finish so you can finish the first job. So the first job will actually finish slower. So it's not always just like roses and everything for async IO. There must be trade-offs. Okay, so I want to present you mainly 3 things that you might not want to choose async for your structure for your application. And mainly 3 things. First thing is that asynchrony is infectious. So the whole thing, your program as a whole needs to be asynchronous. You cannot be say, oh, this part of my program is slow, so I might want to convert to async. No, that does not work. Asynchrony does not work that way. Either you go all in or not at all. So if a single part of your application is slow, then asynchrony might not be the solution. The second one is that async is not parallelism, so it does not solve everything. Okay, let's say you have a slow thing, asynchrony will not automatically make it fast. Okay, slow things are slow. And asynchrony only fixes certain problems in your code that makes your code slow. Okay, so it does not solve everything. And the third one is third-party support, and we'll see that later. Okay. Now this is a simple example demonstrating the first example, the first problem. So this is a simple SQLite 3 example that reads from the database and just close everything and then print the data, return the data, sorry. And so how do you make this asynchronous? Well, as I just said, there's a very simple solution to this. It's very simple to make this asynchronous. You just rewrite the whole program. Easy. Yeah, so what do you need to do to make the above, make this function asynchronous? First, you need to install a new package because SQLite 3 is pre-installed, is bundled in the standard library, but this one, AIODBC is not, so you need to pip install it. And first, you need to learn new APIs because it works a little bit differently from SQLite 3. And then you need to add tons of markers, so everything in green is new things you need to add, and it is not even relevant to your logic. You just need to add those magical things to make your program asynchronous. Okay, so now we have this function, we're good, right? No, now we need to actually use it. Now this is how you use a synchronous function in async IO in the previous example, right? You just call it and you can print data. Now, how do we convert this to use the asynchronous version? Okay, we just set it, just rewrite. Okay, this is if you already have a working thing and you want to convert it to asynchronous model, you just maybe not, right? But relax, that was the easy part. Okay, now. Does anyone see what's wrong in this code? No? Okay, that's perfectly normal because I do this like all the time. When you run this program, you see this. Okay, does anyone see the problem now? I need to add a marker. So what is the problem with that? The problem is that the version without the marker is completely valid Python code, right? A coroutine in an async IO coroutine, I should say. An async IO coroutine is a completely normal structure like everything else in Python. So whether you wait it or not does not affect the validness of your program. So Python will not give you any errors. Actually, I just cheated a bit because Python does give you a warning, but it only prints it to the standard error, so you need to either check it or something. So you need to find in your logs if you have a long-running system or something. You cannot always see that. It's not explicit. It's not very Pythonic, right? But yeah, that is just a minor problem, right? You just write unit tests so you can check the validness of your program. Right. If you want to write unit tests for async IO code, I can just give this. Good luck to that. So this is obviously a very difficult problem, and I have a proof. It's a Stack Overflow question attached to it, and it has, oh, maybe just 31. Yeah, it's a valid question, and it gets asked a lot on Stack Overflow, and it has a lot of duplicates, and this is everyone points to because it has this actual solution. Now, testing async code is a whole other topic I'm not going to talk about right now. And I recommend you to watch the video of a PyCon talk from my favorite speaker in Python. It's Aegis Gerald Davis, eventually correct. Okay, this talk is awesome, and it teaches everything you need to know about testing coding asynchronous code. And he uses examples from Tornado, but the idea is obviously the same. You need to jump through a lot of hoops to get things done, and there are a lot of things in your way that might trip you. Okay, now here's an example. Now, let's say I have this code. This code is very trivial, but it will show you maybe I print the time when I get into this function, and I do something, and in this trivial example, the something is just I wait for 2 seconds. So you can just imagine to switch this to something that actually do things for 2 seconds. Okay, and after that, I print the time. Okay, this simple function just works like this. When I await, you will print the time. Okay, so how do I test this? Yeah, write a unit test, right? Like this. And it passed. Yep, everything's good. So next topic. Actually not. Any problem? No? Yeah, it ran too quickly, right? I waited for 2 seconds, but it just finished at 0.002 seconds. So what happened? It didn't actually run, right? Just like the previous example where I forgot to put a wait. This version of code does not actually run the test, so it doesn't actually validate anything. Because the reason that this happens is that unit tests predates async IO for like 10 years or something, I don't know. So it does not have any information about async IO, and when Python added async IO into the standard library, they never fixed or added any features to unit tests, so it still does not work with async IO. So coroutine methods are just executed, which means that they will return a future to you, which means that the function is not actually run yet. It will run sometime in the future when you want it to run, but you never told the unit test framework that when you want that feature to run, so it never ran. That was a mouthful. Yeah. So did I tell you that this was going to be tough? It is. So how do I actually run that test? You write something like this. I'm not going to go into that because that's just a lot. And there's too much, I'm going to go into it. And you just decorate that test, and now it will run. Okay, so the above code was actually retrieved from that Stack Overflow question I just posted, and you can just Google search how do I test async IO code, and it will probably present that page to you. Okay. So how do you? But you still need to apply that decorator to all your tests, or otherwise they don't run, and you won't get any errors when any test what you forgot to put the decorator to any test in your test suites, and they will still pass, and you will likely not find out, especially when you have a large system with like 1,000 unit tests. Yeah, you might not notice if that particular test run like 2 seconds too soon. You might not even notice. So if you really want to do this, first, if you get any warning when you're unit testing, be sure to read every line of it, because they might contain some relevant information. And second, you might want to consider adding coverage report to your test code. Not just the code you're testing, but the code that the unit test code themselves might need to be included in the coverage report, so you can be sure that if they're ran or not. Okay. And for the asynchronous decorator, there is a ready-made package called Async Tests that contains that decorator for you, so you don't need to rewrite that for your every project. Or actually, there's another solution. You should probably anyway just use PyTest and not the built-in unit test. And the reason for that is that when you do this is a PyTest test. Okay. Yeah. So if I write a PyTest test and make it asynchronous, and it will magically not run. I don't think this is intended behavior, but it just happens. So if you have a PyTest test that tests asynchronous code, and it will magically not run. So at least it will fail explicitly, and you can just add a PyTest async IO plugin. And there are, if you're writing Tornado or Twisted code, there are plugins for them too, and you just mark your tests and will pass. It will pass. Okay, so there's a solution, but you still need to apply that. And if you have some tests already, you might not want to convert them to PyTest just yet. Like us, we're using Nodes for our framework, and we're not planning to convert to PyTest because why? Right? So yeah, this is not a problem, no big deal. But there's more. So does anyone, are there anyone familiar with this meme? Like when we're supposed to doing science, we're just writing code, everything is wonderful, but actually we're just doing engineering, and we just tape everything together and pretend that everything works, right? Async IO is just an engineering solution to me. It is just not good enough for Python, I think. Because first you need to write a lot of boilerplate, and you can very easily make errors. And also the API is pretty immature, at least I think so. And actually the API is a good part because it is supposed to be immature, right? Async IO in 3.4 is only provisional. I think it's called provisional or something similar. And in 3.5 it is just about steady, and it's still under very active development. So yeah, it's bound to be pretty immature, but that's okay, it will improve. But the other two, I don't know, it might not. So this is I think everyone writing Python at some point will have used requests for something, so this should be pretty familiar to everyone. I just ran through some URLs in the list maybe, and I collect everything, and if the URL returns 200, I just put the response, the content of the response into an array and just return it. Okay. Now, if you want to rewrite to, kudos to Andrew, rewrite with AOFTTP, you just do this thing. Okay. So you have to do a lot of rewrites. Obviously, I just mentioned that, but it still works, so everything is fine, right? No. As Borma said, one does not simply add async and awaits. It will not magically make your program async. Well, actually it will, but this one will not actually run faster than the request version. I think probably slower. because of the context switch. Now, the reason for that is we run a for loop, and in every iteration of the for loop, we wait for the content, right? So we get the first URL, we send it, and we wait for it, and we retrieve the content. This is exactly like what we did in the synchronous model, right? We send the first request, wait for the response, process it, and we send the next request, wait for it, and process it. This is synchronous, as the previous example. Okay. The first part, we send the request and we wait, the white line, we wait, and then we need to retrieve the result. This is completely synchronous, even though you're writing asynchronous code. Now, if you want to make this truly work as you think you should, you need to do this. Instead of running every coroutine, you need to collect all the coroutines you have and then call asyncio.gather and tell asyncio to run those coroutines at once. Now this will actually be run asynchronously, and you will not wait idly for the content. So yeah, if you have worked with threads, you might notice that this looks a lot like thread joining. Like you just blatted out threads out there and you just wait for everything to complete at the end. But if we're using the same API, why are we not just using threads? Because this is not, at least API-wise, this is totally not better. Oh, by the way, we're talking about asyncio gather. Can I make a complaint? Maybe someone can maybe relate to Guido or something. There's an asyncio.wait API, and there's an asyncio.gather, and they do pretty much the same thing, but they return different things, right? Asyncio.wait returns a set of features, and asyncio.gather returns the result directly. But the API is different. You see, when asyncio.wait, you give it a sequence of features, but in asyncio.gather, you need to actually expand that sequence into the function parameters. And why? Can everybody tell me why? I don't know. And also, when you're calling asyncio.wait and the future maybe list or something is empty, it will give you an exception. And why can't we just have maybe just do nothing as a result? And even worse, why does not asyncio.gather give me an exception? These two are completely the same under the hood. They just return different things, but they just do an extra check in asyncio.wait. And why? I don't know. I step on that strange thing a couple of times, and now I learn. So yeah, everything is good, probably. Now I know the difference. I think I'm running out of time, so I'm gonna go through this quickly. Are there, if asyncio is actually not your thing, maybe I just dissuaded you in my previous presentation that you probably should not use asyncio, then are there alternatives? Probably. You can still use concurrent and multiprocessing if you want to, right? And they work just like you expect them to. Maybe not very elegantly, but they will get the job done. Also, there are greenlets if you don't want to infect all your program to become asynchronous. And greenlets actually shares a pretty common idea with asyncio. It is also sort of single-threaded asynchrony, but the API is a bit different, and how it works is also a bit different. And if you are using CPython and you have a C compiler, you might want to check that out. Okay, it's at greenlet.readthedocs.io. And also there's a threading, right? Just threading. And threading actually works pretty well if you are dealing with standard I/O. If you're dealing with I/O. For example, if you're dealing with serial input or HTTP input, TCP input, something like that. Because Python does not hold the GIL when it's waiting for I/O, for external I/O. So when you use threading, it will not block the thread when it's waiting for serial input. Okay, so it will actually make your code a bit multi-processing. Multi-threaded. Okay, and I know a lot of people will mention GEVENT. I personally don't like GEVENT because I don't like monkey patching. But if it works for you, then it works for you, and I have no problem with that. Just don't bring that to our company if you ever joined us. Okay. Okay, this I'll probably just skip. Yeah, so if you ever use Go, I have a lot of problem with Go, but Go's asynchronous API is excellent. You should probably check it out, and after you check that out, you will find that asyncio API barely like bearable. Like the Go model is pretty good, at least API-wise. The implementation I cannot say is probably not very good. And this is Python, is API-wise not very good. Okay, as I said, Go's API is pretty much very like science. It's not exactly science, but it's pretty close. And asyncio is just tapes. Yeah. Okay. Oh. I see. Oh, okay. So to recap, you've heard me rant for 30 minutes now, and you've heard a lot of complaints, and I didn't even give you one constructive advice. I just tell you to simply just tell you to not use asyncio as much as possible, and more rant on APIs, on the ideas behind asyncio and just everything. Sorry, this is just a rant. This is not really a talk. And I give some suspectable advice that to you to use a third-party library that comes out of nowhere called Greenlets. It's not actually like that. It's a pretty good library. But seriously, after this talk, if you want to look into asyncio or other asynchrony models, I just want to advise you to maybe think twice, okay? Because it will probably not solve your problem, especially if you have very specific problem like we do. Okay, and if you decide to actually use asyncio, you should be prepared to jump through a lot of hoops because you need to. Okay, and if you are a bit dissuaded, there are alternatives you can use. So these are my advice, and here's your sword. Thank you.
발표해 주신 Tzu-ping Chung님 감사합니다. Thank you for the speaking, Tzu-ping Chung. 질문 답변 시간을 진행하도록 하겠습니다. 질문 있으신 분은 마이크가 걸어요.
Thanks, you put a proper fear of God into me on that one. I mean, that was sort of your goal. One of your comments early on was that using any bit of this infected all of your program. In watching your actual presentation, my sense is that if I've got just a single file I'm using as a module to import, there's a couple of functions I consider public, a couple I consider private. If the public ones are being treated as synchronous, and everything else in there I've replaced with asynchronous methods, that actually does give me enough isolation that the asynchronous nature of the private methods is not going to leak out and affect the rest of my code. Is that a fair assumption? Is that a reasonable way of encapsulating this danger?
Can I use this? Oh. Yes, that is absolutely correct. You can use that. Yeah, but you need to jump through other hoops, like because you need to create a separate loop, event loop for every instance of your module. You can't just use the built-in get event loop function. You need to build your own event loop. Yeah, but aside from that, it's actually correct. Okay, so yeah.
I have actually a question about want to share some stuff. You comment asyncio many points, and it's true. Asyncio is not single about. It needs right now more documentation, more advice how to use properly, need more async clips. That's true, but it's solid. But what I want to point, asyncio is not compatible with synchronous code. If you need synchronous approach, just use it. If you need async, use async libraries. Asyncio compete with existing asynchronous libraries like Tornado and Twist. And from this point of view, asyncio code looks pretty nice and easy to understand, to maintain. It's better than Tornado code. And that's the main point what I want to stress. Don't try to compare synchronous and asynchronous. Every approach has good points and weak points. But if you compare different asynchronous libraries, looks like asyncio is not bad.
Yeah, it's. I think asyncio is already the best solution, best asynchronous solution in Python. Yeah, but if you compare it with other languages, maybe with Go or with C#, or I don't think it's actually that mature.
I think I use the word iteration, and I'm pretty sure nobody would have Python 4 and compatible with Python 3 right now. So we cannot change language very fast without backward compatibility. But we try to do the best. We have async def and array syntax right now. In Python 6 we most likely will have asynchronous core key with yields inside, and we do it. But we cannot just draw existing code and say we invite very new language with cool syntax, but it's not compatible with your program. Sorry.
Yeah. Yes, I agree. I agree. Yeah, so maybe we just wait for Python 4. Maybe. I hope so. So time.
지금까지 알려주신 추킹창님께 박수 부탁드립니다.